Ecopolis, future megacity. It's not a real place, but a possible blueprint for city life in 2050, unless technology can turn things around. Overcrowded, polluted, and an environmental mess. This is Ecopolis. In this groundbreaking 6-part series, Nobel Prize-winning scientist Dan Kammen reveals the technology that could transform our cities and usher in a brighter future. This episode, Buildings.
The energy demands of our buildings are simply unsustainable. If we can't find ways to make them cleaner, we commit ourselves to a warming future.
Using Ecopolis as a testbed, Kammen investigates new cutting-edge technologies.
I have to be sure that the technologies will deliver by 2050. And I've got to be sure that they're cost-effective and user-friendly.
He hopes to discover those technologies that can revolutionize our future and save all the world's cities from possible disaster. In 2050, most of us will live in cities like Ecopolis. Heating, cooling, and lighting its buildings sends 100 million tons of carbon into the atmosphere every year. Experts say that's a recipe for pollution and global warming.
Buildings are the 800-pound gorilla in the room. 2/3 of all energy is consumed there, and to get the same services we get today, buildings are going to have to be dramatically redesigned if we want a low-carbon future.
In this episode, Dan Kammen explores futuristic technologies from 4 visionary scientists claiming to revolutionize our buildings. Kammen must choose only one of the 4. First up, a revolutionary technology that puts the lid on wasted heat.
Buildings today are tremendously inefficient. They leak heat out of the walls, out of the corners, out of the roof, and it's a real tragedy. And here we are concerned about global warming, and our buildings heat the outside world around them almost as much as their insides.
Our homes and workplaces are raising the planet's temperature, but we can save ourselves by saving heat. This is one of the strangest materials known to science. It helped a space crew survive a frozen hell on the surface of Mars. This man thinks it can transform our buildings and maybe transform the future of planet Earth. 2050. Ecopolis is booming. New buildings are rising everywhere, burning energy by the second. This demand for power pushes up greenhouse gases and pollution. 40% of a building's energy consumption is used for heating and cooling. But a staggering 1/3 of that simply disappears into thin air. Construction expert Don Young wants us to see our city's buildings through new eyes. He thinks if we could see energy as we waste it, we'd take action in a flash.
If people could see the world through these infrared eyes, the amount of sensitivity to these issues would skyrocket.
The yellow and red parts of the image show where most of the heat is escaping.
It's just phenomenal. I'm in this business, and I'm amazed at the amount of energy being emitted.
It shows there's a towering inferno raging through our cities.
I mean, these buildings look like they're on fire, really.
The problem is poor insulation. Buildings alone waste 13% of global energy production. That's equal to nearly 4 billion barrels of oil a year. We're building entire power stations just to heat up the sky. It's an unbelievable waste. Ecopolis offers a sobering glimpse of the future. It is packed with 18 million people living and working in buildings. But Don Young wants to reinvent our buildings. He's racing against rival companies to develop an astonishing material to keep heat exactly where we want it, on the inside. There is one place where extreme insulation is essential: the frozen wastes of space. And if this insulation can work in space, it might be the answer down here on Earth. Don Young discovered that NASA spent 2 decades investigating new kinds of insulation. They developed one of the most exotic and beautiful substances known to man. This astonishing material is called aerogel. Technically a solid, aerogel looks more like a trick of the light.
People refer to it as frozen smoke, and in some sense it is. It seems to be there just for the moment.
An incredible 99% of aerogel is nothing but air. It lets light through, but it won't conduct heat. This amazing property arises from its unique structure. Aerogel is made from a jelly-like substance, part liquid, part solid. The solids are fine chains of silica, surrounded by alcohol. To dry the gel, the alcohol is replaced with liquid CO2 under high pressure. As the pressure drops, the liquid CO2 becomes a gas. It bubbles away and leaves behind tiny air-filled pockets that are 1,000 times thinner than a spider's web. This elaborate honeycomb of air blocks heat instantly. In the 1990s, NASA put aerogel to the test in one of the most extreme environments in the solar system: the frozen landscape of Mars. On the red planet's surface, temperatures can plummet to minus 100 degrees Fahrenheit. Far too punishing for the sensitive equipment inside NASA's robotic probes. So NASA began encasing the electronics on Martian explorers in aerogel. If this advanced insulator failed, it would be a multi-million-dollar disaster. But aerogel delivered the goods. The Martian explorers beamed back stunning images and survived 3 frigid months. Don Young knows aerogel is the best insulator ever invented. But there are big problems with applying the space-age material in an urban environment. Aerogel is expensive and very, very fragile.
The main problem with the laboratory aerogel that had been around for quite some time is its fragility. It is easy to crush.
One squeeze, and aerogel explodes in a shower of dust.
It is easy to break and just very hard to imagine using it in any type of industrial setting.
Young's company spent 7 years making aerogel tough enough to use in buildings. Their solution is simple, but brilliant. The wet gel goes around a blanket of polyester fiber. This blanket provides a skeleton for the material, making it strong and surprisingly flexible. The finished product still has aerogel's incredible insulating properties, at a fraction of the cost of the material sent to the red planet. This is dry ice at minus 109 degrees Fahrenheit, as cold as the surface of Mars.
When I put my hand on this ice, I suffer almost immediate frostbite. Insulate that with 3 millimeters of our aerogel material. I can put my hand on this indefinitely for the day, if necessary.
If aerogel can block the cold, it should be just as efficient at keeping heat in. Young's betting his right arm on that. 3 millimeters, or 1/8 of an inch of aerogel blanket, stops a flame roaring at more than 3,000 degrees Fahrenheit.
We've been able to maintain all the magical properties, all the thermal properties that make the aerogel so important. Now we're in the midst of introducing the material into the building and construction industry.
Young's aerogel blanket is incredibly effective at insulating walls and roofs. But 30% of the heat lost from a building goes straight out of its windows. So Young is experimenting with see-through aerogel.
The holy grail of of aerogel would be to one day be able to make an aerogel that could be transparent enough and strong enough to provide insulation within the window structure itself.
To plug the last gaps in our leaky buildings, Young believes we need aerogel window panes. So far, these high-tech windows are too fragile. Vibrations from a passing truck could be enough to shatter them. But Young is confident scientists will crack this problem. If they succeed, it could have a real impact on Ecopolis. The city's buildings kept hot or cool for a fraction of today's energy cost. Don Young is convinced that aerogel's glory days are coming.
I think that we will have aerogel in every building. Aerogel will be as common in 2050 as materials like plastic are today.
Aerogel insulation, a very futuristic idea. But is it the best weapon for the war on carbon emissions? Top scientist Dan Kamen has the final say. He will decide if aerogel can crush Ecopolis's carbon footprint. The Center for Alternative Technology crunches the numbers, providing data for each technology's impact on Ecopolis's carbon footprint. This weird futuristic material scores an amazing 29% reduction in emissions. Maybe it could alter the future of Ecopolis. But Kamen has reservations. Despite its high score, aerogel still has limitations.
One of the issues with aerogel is that we manufacture it today in sheets that you can place into walls, but it's nowhere near as convenient as some of the insulants that you spray in through gaps.
Kamen has 3 more technologies to explore before choosing one to help Ecopolis 2050 survive. Aerogel tackles the wasted energy in our leaky buildings. Next, a technology that claims to be able to throw a new light on city life. Day and night, all these buildings devour energy, most of it for artificial light. Electric lighting alone uses so much power that it produces 3 times more carbon dioxide than all the world's aircraft.
Lighting consumes about 1/5 of the world's energy. It's a very inefficient and old technology. In fact, it's one that the bulbs we use produce more heat than they do light.
We need a new way to light up the world's buildings. This man wants to harvest sunlight. He imagines sending natural light to every dark corner of every tall skyscraper in every megacity. 24 hours a day, offices, factories, and malls pump out artificial light. The shocking thing is that much of it blazes in broad daylight. Duncan Earle thinks this is an unacceptable waste of energy. He blames the traditional light bulb.
The main reason light bulbs are energy inefficient is that they produce mainly heat.
In fact, only 5% of the energy powering a conventional bulb becomes light. The other 95% becomes wasted heat. Earle needs to rethink the century-old light bulb. The answer may be in the sky. Natural sunlight strikes building exteriors all day.
I think the thing that annoys me the most is when I walk into a nice commercial building that has the great skylights, great windows, but they've all been equipped with blinds or with shutters, or in some way they're blocking out that natural light.
Sunlight streaming through windows is one answer. But sunlight at the wrong angle is glare. And it can't reach a skyscraper's innermost recesses. Earle wants to concentrate sunlight and redirect the rays wherever light is needed. His big idea? Mirrors. Turns out the best way to collect sunlight is a curved mirror. Most mirrors are made of glass, and curved glass is expensive.
The eureka moment in this development was realizing plastics are the key.
Plastic mirrors are a cheap alternative, but there is a problem. They melt. Nobody had ever before manufactured an accurate plastic mirror to collect sunlight.
Everybody in the establishment, and Solar said, oh, you can't do that. Plastic mirrors, they can't be made accurately enough. It's too difficult, it's too much of a challenge.
If Earl's plastic plan failed, he would see over 10 years of work come to a crashing halt. He had to design a sun collector able to withstand temperatures of 150 degrees Fahrenheit. And to be cost-effective, it would have to survive at least 20 years. Earl made his breakthrough by combining acrylics with conventional plastics. This amazing new material stands up to high heat. And Earl had the plastic he needed for his solar collector.
What we have here is probably one of the world's best, most accurate profile parabolic plastic mirrors.
Earl had risen to his first challenge. The plastic primary mirror costs $100, compared to the $3,500 glass alternative.
This is our solar collector, and as you can see here, we're using a large mirror to concentrate the sunlight, about a square meter of sunlight, into a smaller secondary mirror.
Earl's plastic mirror concentrates the light cost-effectively, but to do its job right, it has to stare into the sun all day long. And that means focusing on a moving target.
The clever part of this technology is really the solar tracker. It uses about as much energy as a small Christmas light, but it's extremely accurate in how it points towards the sun.
The system's GPS module knows exactly where it is on the planet and also what time it is. The device uses this data to compute the sun's exact angle and elevation. All day, a small motor keeps the dish on the same track as the sun, always pointing directly at it and collecting maximum sunlight. Earl has the tools to concentrate light. Now he needs a way to direct that light deep into a building. Earl drew upon an existing proven technology, fiber optics. He wanted to use plastic fiber optics to keep costs down. But he soon ran into a problem. They melt. Earl's revolutionary concept was to be selective about the light he collected. He needed plastic-friendly rays.
With our system, we're only concentrating the visible light. The infrared light, the ultraviolet light, which can cause heat buildup and product fading, is rejected by the secondary mirror.
Earl's system filters out the hot wavelengths of sunlight that can melt plastic. And it works.
This is a sample of the optical fibers we use with the hybrid solar lighting system. As you can see, these fibers are extremely flexible, they're very low cost, and they're made out of a very pure acrylic that then is coated with Teflon, which allows the light to very efficiently travel within the fiber. And just as with a single fiber, when light from a large artificial source is piped in one end, light comes out the other.
Earl is testing his revolutionary new technology in a local furniture store.
Inside the building, the optical fibers are distributed to individual light fixtures. Roughly 2 of these small optical fibers equal a 60-watt light bulb.
All well and good, but what if the sun isn't shining?
The system uses a photosensor to monitor the intensity inside of a building, so as the natural light increases or decreases, the artificial lighting is automatically ramped up or decreased in response.
Earl calls his new technology hybrid solar lighting. And it may offer residents of Ecopolis more than a break on carbon.
The clearest benefits are energy savings, sometimes as much as 80% plus energy savings. But by far the most interesting benefits are more the secondary health-related benefits.
Las Vegas is home to the New Horizons School. Earl's installed his system here to help students with attention deficit disorder. It seems incredible, but replacing artificial light with Earl's natural sunlight system actually helps calm the children, keeping them focused and improving their performance.
The hybrid lighting has brought peace, it's calmer, and I think the students are able to focus longer on their activities than they have in the past.
You're focused more.
It feels calming. It just relaxes you.
I'm thrilled to know that we can harness the sun's energies and use it in such a smart, effective way.
The possibilities for hybrid solar lighting are endless. The sun could be piped into places where darkness is the norm. Imagine basements, road tunnels, and subway stations, all bathed in natural daylight. Dan Kamen can pick one technology to save Ecopolis from urban meltdown. Will hybrid solar lighting impress him? Kamen has the carbon counter statistics at his fingertips. The results are surprising. On its own, this lighting system would cut Ecopolis's carbon emissions by only 4%.
Hybrid lighting is very attractive, but compared to all the other energy use in buildings, it may not be that big of a savings.
But Kamen still sees huge potential.
Solar hybrid lighting is a great package. It provides a way to harvest natural light, it's an easy-to-deploy technology, and it provides a very high-quality lighting environment.
Kamen has put 2 technologies under the lens, but has more options to review. The third could save Ecopolis from meltdown. Nobel Prize-winning scientist Dan Kamen can pick one technology to save Ecopolis from urban meltdown.
Cities today are concrete jungles with asphalt roads and concrete buildings, and they cause their own heating effect. They're warmer than the surrounding area because of all of that absorbing material.
But in sunny California, botanist Frank Almeida thinks he can cool our cities with a forward-thinking design and help from Mother Nature. Our cities are getting hotter and adding to the planet's rising temperature. If we don't act, by 2050, cities like Ecopolis could be as much as 4 degrees hotter than they are today. Adding to the problem is a phenomenon called urban heat islands that experts say will make killer heat waves even deadlier.
The urban heat island effect is one of the most dangerous things confronting humanity today.
A city's huge expanses of man-made material absorb heat from the sun and release it back into the atmosphere. Narrow streets and high-rises trap the hot air. Our buildings are colossal radiators, and the temperature is soaring, up to 10 degrees higher than surrounding rural areas. So why is the countryside cooler? When sunlight strikes plants, they sweat, as humans do, releasing water vapor. This evaporation dissipates enormous amounts of the heat caused by sunlight and helps to cool the air. It means a field full of plants will always be much cooler than a city block made of concrete. Frank Almeida is resident botanist at the California Academy of Science. He set out to fight the urban heat island effect in San Francisco. The idea was to reproduce the natural cooling cycle of the countryside in the heart of the city. He worked to create the world's largest living green roof. The building took 10 years to design and build. The huge 2.5-acre roof mimics San Francisco's 7 hills. But this ambitious design gave Almeida some big problems. His first challenge? How to keep more than 1,300 tons of soil from hitting the sidewalk.
One of the challenges of building a living roof on this kind of a building with several domes was to find a way to keep soil from sloughing down these slopes of 60 degrees.
Almeida's solution to a rooftop landslide was to set the soil in bio-trays. He needed a material that rainwater could penetrate, but was strong enough to hold the soil and plants. The answer? One of the strongest and most versatile natural materials known to man, coconut fiber.
These trays allow water to seep through the tray. They allow roots to grow into each other so that they can hold themselves together.
Almeida found a great way to keep the soil from sliding off the roof, but he still faces a big challenge. How to prevent the building from collapsing under its living roof's 1,300-ton weight.
The first layer is a layer that seals that roof off a polypropylene fabric layer, an insulation layer, another polypropylene fabric layer to actually protect the insulation.
This complicated multi-layer system protects the building. Now Almeida can turn his attention to his big passion, plants. Plants need light and warmth to survive, and the sun provides plenty of that. But plants also need water, and Almeida wants the green roof to be self-sufficient without wasting energy on irrigation. He must find a way to harvest every last drop of rainwater. And there's a simple but effective solution.
The egg crate layers is actually where excess water will actually sit and be available to the plants. Another polypropylene layer to prevent any root penetration. And then the rest, we call these the biotrays that were actually designed specifically for this project.
And by capturing rainwater, Almeida's green roof delivers a huge payoff. As rainwater falls, it picks up an unwelcome guest, pollution, in the form of nitrate and phosphorus particles. Much of this toxic material falls on roofs, but within hours it is washed off to seep into groundwater. But soil contains bacteria that convert toxic substances into plant nutrients. Green roofs absorb up to 98% of rainfall. Almeida's living roof alone could prevent 2 million gallons of rainwater a year from carrying pollutants into our ecosystem. Almeida's team is monitoring their living roof's air temperature to gauge its impact on the urban heat island effect. Research on smaller, mature green roofs is startling. On an average 65-degree day, temperatures on a normal roof soar to a staggering 90 degrees Fahrenheit. But a green roof runs a cool 60 degrees. All thanks to evaporation from its plants.
Prior to building this living roof, I used to come up onto the roof because we occasionally would grow a potted plant or two. It was hot, it was dry, you never saw any insects and you never saw any birds. Creating a living roof has dramatically metamorphosed this entire rooftop in a very positive way.
Large-scale green roofing could make a huge difference in city temperatures and would transform skylines. Planting just half of Ecopolis's roof space would have a noticeable effect on the city's temperature, cutting it by up to 18 degrees Fahrenheit. Almeida feels we have no choice.
This is a wonderful opportunity to do something that's great for our planet, and the time is not better than now.
Climate expert Dan Kamen is scrutinizing technologies to see which would do the most to save Ecopolis from urban implosion. To help Kamen decide, the Center for Alternative Technology crunches the numbers and gives green roofs a carbon score. The result? A surprise. The megacity's carbon footprint would shrink just 4%. Level with solar hybrid lighting, but far less than aerogel.
The carbon score for green roofs isn't great, but I really like this technology. It provides shade, it cools the roof, it brings the natural world right up to our built environment. It's a very attractive thing. It also harvests rainwater. This is a very nice thing to do in the urban setting.
Low score or not, green roofs tackle a major urban problem. Without them, city temperatures could continue rising, turning urban heat islands like Ecopolis into hell on Earth. Kamen has studied 3 possible technologies. He is impressed with them all, but can choose only one for Ecopolis. And there is still a final idea to explore.
Today, buildings are at the end of the line. Power plants send power down the grid to them, and that's it. We need to fundamentally rethink that and see if buildings themselves can become power plants.
One ideal solution for 2050 could be a city that powers itself. Imagine Ecopolis with no power stations, no need for fossil fuels, no carbon emissions, no global warming. Science fiction or realistic vision? This could be the answer: the sun. Jeffrey Grossman is a scientist at University of California, Berkeley, and he has seen the light.
One of the biggest challenges we face is to reduce our dependence on fossil fuels. And there are a number of different ways we can do that, and there are a number of renewable energy sources, but the sun is special. And the reason it's special is because in 1 hour, we get enough energy from the sun to power the planet for a year.
Solar energy technology isn't new. Generations have struggled to harness the power of the sun. And one town blazed the solar trail. In the 1970s, Germany decided to go nuclear. Planners picked Freiburg as a reactor site, but many residents had other ideas, and the town erupted in mass demonstrations and riots. The government backed down, but that exercise in people power left the region of Saxony short of electrical power. Today, Ralph Bushman heads Freiburg's Institute for Solar Energy. In the old days, he took to the streets against nuclear power.
The protesting and the crazy, wild, future-thinking, future-orientated protest was combined with a serious fear against the nuclear industry and nuclear power.
Freiburg's eco-warriors looked to the sky and their city's 2,000 hours a year of sunshine. The town quickly became a center for developing solar technology of all kinds, especially photovoltaic or PV devices. The goal was to turn sunshine into electricity. Most PV cells consist of 2 layers of silicon, sandwiched between metal strips. The top layer of silicon has more electrons than the bottom layer. This creates a difference in charge and therefore an electric field. Packets of light from the sun, known as photons, knock some of the electrons loose. They catapult out of the silicon to the metal strips, producing electricity. Ralph Bushman and his colleagues were pioneers in PV technology.
First instruments were some photovoltaic panels producing the electricity to feed some batteries and small equipments. And standalone systems. That was it. So it was only thinking in small scale.
But soon, solar panels sprang up all over Freiburg. It became one of the world's first solar settlements. Every solar house produces more energy than it needs. Owners sell the excess to the national grid. Each residence is a mini power station. The star of the town is the world's ultimate solar-powered house, the Heliotrope House. On the roof is an impressive solar sail of more than 1,000 square feet that tracks the sun's path across the sky. The whole house rotates to follow the sun throughout the day, and it generates an incredible 5 times more power than it uses. Freiburg is an incredibly successful eco-experiment. It proves that harnessing the sun's power works. But the downside is the price. And this is what has delayed the widespread adoption of solar technology. Ultra-pure industrial silicon is expensive. It costs up to $225 a pound. And the high initial cost of installing silicon solar cells has kept this technology from becoming commonplace. Enter the pioneering Grossman. He is a special kind of scientist, a nanoscientist.
We're going to need to bring the cost of solar cells down. And nanotechnology offers a critical pathway to doing that because it allows us to use completely different materials, which are less expensive than silicon, in making solar cells.
Grossman wants to replace the silicon in PV cells with a much cheaper material, carbon. It's one of the most abundant elements in the universe. But to make his PV cells, Grossman uses a special type of carbon called fullerene. This substance is at the forefront of the new science of nanotechnology, the science of the small. And this is where Grossman's nanoscience comes in.
Well, the nanoscale is very special for materials. And the reason is that when you get to this tiny, tiny size scale, the behavior of these materials changes.
A human hair is a massive 100,000 nanometers thick. A red blood cell is still 10,000 nanometers across. To reach true nanoscale, you've got to go really small. DNA, for example, is just 2 nanometers thick.
The nanoscale is the scale of the very, very tiny. It's a billionth of a meter.
Working at this scale brings challenges. Currently, Grossman's nano PV cells only capture 6% of the energy that hits them. But he's got a solution. To improve efficiency, he wants to exploit one of the unique properties of fullerene. Alter the size of a particle of fullerene, and it completely changes its color. A material's color dictates how well it absorbs light, which in a PV cell would make it more efficient at turning sunlight into electricity.
Now, by changing the size and then changing the color, we have the opportunity of changing how something absorbs light, which means that we can make it more efficient at absorbing light from the sun.
Grossman and his colleagues have cracked the science, but they still face a major hurdle. Traditional silicon cells are around 15% efficient. Grossman needs to improve his 6% efficient nanocells to this level and beyond.
Solar cells based on nanomaterials can already power certain things like your watch or calculator or even your cell phone because they're already at a 5 or 6% level of efficiency. But in order for them to be efficient enough to power your house, we need to boost that efficiency by a factor of 2 or 3.
Such a breakthrough is not far away. It has taken less than 10 years to get nano PV cells to this efficiency. Grossman believes that by 2050, they will be at least 20% efficient. And unlike their silicon forerunners, nano PV cells are lightweight and more flexible. These added benefits mean Grossman need not limit nano PV cells to powering buildings.
I get really excited about taking these materials and their new properties and making new devices out of them.
Because the new generation of solar cells are far smaller, their applications are virtually limitless. Grossman believes they can work in cars, clothing, and even paint. In Ecopolis, buildings could be sprayed with nanophotovoltaic paint in any color you choose, and presto, power for your home. It's truly a revolutionary technology. The carbon counters have calculated what would happen if Ecopolis adopted nanophotovoltaic cells. The results are impressive. A hefty 51% drop in carbon emissions, making this idea a real contender for first place. It's the final idea for our resident green professor, Dan Kamen, to mull over. But Kamen has some doubts about this radical technology.
Solar buildings are a very attractive concept, but there are some things I'm going to have to think about. One is that photovoltaics are very expensive today, and the other one is that we don't have a storage system built in. So while these buildings can power themselves during the daylight, at night, we have a problem.
Kamen's time is up. He has to decide which technologies the buildings of Ecopolis should adopt. How will the megacity skyline change as a result? Dan Kamen, professor of renewable energy, Nobel Prize winner, and top government advisor, is assessing 4 new technologies. He wants to know if they can help us survive the future. By 2050, experts say carbon emissions will be destroying Ecopolis. It suffers rising temperatures, extreme weather, and increased pollution. Residents live in energy-guzzling, inefficient buildings that are at the root of the problems. Radical action is needed. Kamen has his choice of 4 carbon-busting technologies. He can choose just one to slash the 100 million ton carbon footprint that heating, cooling, and lighting Ecopolis's buildings create.
In thinking about buildings, we come back to our basic criteria. They have to be effective at reducing greenhouse gas emissions, they have to be cost effective, and they have to be things that we can deploy in all buildings all over the place.
Duncan Earl controls sunlight. His hybrid solar technology could revolutionize how we light our buildings. Carbon saving to Ecopolis, 4%. Cameron likes this idea, but has reservations.
Solar hybrid lighting is a very attractive technology, but it's not going to beat our energy bill all the way down, which is where we need to get to. It also requires a fair amount of infrastructure on the roof to bring in the lighting system. So I'm going to think about just how far this could take us.
Frank Almeida believes that carpeting the roofs of our cities in vegetation will help overcome the urban heat island effect. But the 4% of carbon saved by green roofs doesn't convince Cameron either. He fears older buildings couldn't stand the extra weight.
The real issue for green roofs is how many of our homes can really have these installed. Since we can't do it as a retrofit, it needs to be new homes designed for it. I'm just not quite sure if this is going to be a big hit.
Cameron has to decide. Hybrid solar lighting and green roofs score only 4% each. Can that keep them in the running? He must narrow the field.
If I have to discard two technologies, it's going to be the solar hybrid lighting and the green roofs. They just don't give us enough carbon savings for the buck.
That leaves two technologies, aerogel and nano-solar technology. Jeffrey Grossman plans to transform the way we power our lives. He sees a future in which we paint solar panels onto walls and vehicles. If the concept takes off, then buildings themselves would become power stations. Ecopolis would slash its carbon emissions by 51%. Nano-solar takes pole position for carbon savings, but Cameron knows its limitations.
Solar energy, of course, is not a resource that's shared equally around the world. There are some northern cities and far southern cities and cloudy areas where this is not going to be a winning option.
And then there's space-age aerogel. Insulating every building in Ecopolis with aerogel would cut carbon emissions by 29%.
The cost of aerogel today is fairly high. That's largely because it only has a very few applications. It was developed for the military, it's got some specific uses with spacecraft and various things. Getting it as a widely produced material for home use is a whole nother market. Hopefully those costs will come down as it scales up, but we have to see. The proof is in the pudding if that really happens.
Cameron's run the data, but it's not just about numbers. Which technology will be affordable and user-friendly for the citizens of Ecopolis? Aerogel or nano-solar technology?
Solar power for your home's rooftop and aerogel as insulation for the walls are a bit like peanut butter and jelly. They're each fine by themselves, but together they're great. You make a home well insulated with the aerogel, you need less power from the solar panels to charge it up. They're a wonderful combination. I wouldn't want to pick one versus the other. I'd like to see both of them evolve.
Cameron doesn't have that luxury. It's one or the other, but which?
If homes can become power plants, that's going to offset a great deal of not only the energy use in the home, but it provides the ability to sell it back to the neighborhoods, to provide it back into the grid. That's giving you extra value and extra services that even a very good insulator won't get you. So I would give the nod to solar on that ground alone.
Dan Cameron's decision revolutionizes Ecopolis. Solar panels blanket roofs. Walls get nano-photovoltaic coatings. And the megacity starts to harvest the sun's rays, producing its own power. It's a masterstroke, one that cuts the megacity's carbon output by 34 million tons a year. Used in all the world's cities, it could help save planet